Welcome to the Viessmann Academy. My name is Rob Waters, and on behalf of everyone at the Viessmann Academy, we welcome you to today's webinar on the Viessmann Airflow Plus. And this is a little bit of a departure from Viessmann, is that we're getting into the heating of air rather than the heating of water. We hopefully enjoy this webinar today. There is the opportunity to ask questions. There is a little pull-down box on your GoToWebinar software where you can ask questions. So if you want to post a question, type it in there and we'll look at those at the end. So again, welcome and enjoy. So the Viessmann Airflow Plus, it's a hydronic forced air handler, and this is a brand new product launched in Canada in just recently, July of 2015. The announcement just went out last week that we were good to go on this. It is a product, I know there was a couple of people from our US customers who had signed up for this webinar. Just to note that this is a product that's launched only in Canada at this point in time. I don't know what the plan are for the US because the US market is run a little differently now. So this is only available in Canada. So this is basically an air handling unit, but it's loaded with tons of features, and it's got a lot of unique features that really we think make it one of the the best available hydronic air handlers on the market. We've designed this to be a perfect match for our Viessmann condensing boilers, and we really think that it can really round out our Viessmann system. It is available in 3 sizes, and I'll go through that in a little further slides. It is made in Canada, so a lot of the componentry is going to be readily available, and it's going to be technology that most of you are familiar with. As I said earlier, this is really a new member of the Viessmann family, and we've been in the water heating business for years with condensing boilers, system controls, solar systems, indirectly heating domestic hot water, and the whole package that pulls all that together. But the hydronic air handler is never something that we supplied in the past, so now we are able to supply this, and we think it really fits the mold of Viessmann products of being high quality, durable, reliable, long lasting, and loaded with features that you won't see in other products. So it's a good fit in this Viessmann family. Here's a look at the construction of this product. It is a very compact, low profile unit. If we start at the top there, top left-hand side, you've got the heating coil and then the integrated 3-speed pump built in right below that. So that whole unit is kind of made together. The side panels, one of the things that's unique about this product is going to be how quiet it operates. And the reason it's so quiet is because we really build this thing with really tight trim and fit and finish. So you've got reinforced foil-backed insulation, and you've got gasket seals on all the panels, and so this thing is not going to be a rattly shake box. It's going to be quiet, smooth operating, and you combine that with the dynamically balanced fan and then the ECM motor. It's going to be a great feature to offer your customers. They're not going to hear this thing banging. You combine that with a Viessmann boiler, condensing boiler, which is virtually silent. It really makes their whole mechanical system operate very, very quietly. At the bottom of that unit, you've got an integrated filter rack. All of the water connections are basically either 1/2 inch or 3/4 inch FIP water connections. They're at the back of the unit. So again, aesthetically, when you have this thing piped up, it's going to look very nice because all the piping connections are from the rear. And then I'll show you later on how you can change the return air connections to suit your job site. There's a status light at the top right corner of the unit, which gives you a status of what's going on, but also indicates faults and alarm situations. So if your customer comes down and then sees that flashing, they'll know right away that something's wrong. All of the panels on this unit are modular. They're all held in place with a Phillips machine screw that you can take on and off very easily. So I'll show you later how you can really change the orientation of this fan coil to suit the requirements of your job site. It's very easy to take it apart and put back together again. And I think any of the people are used to working with sheet metal and fan coils, they're going to really appreciate how easy this thing is to work with and how versatile those panels. And again, it looks great when all the panels are on. It's a really high quality coating that makes this thing look very professional. There's a door safety switch, so it interlocks with the power supply that connects into the main control unit. And of course, the drive, the heart of this unit is the ECM fan, which gives you a lot of versatility in how you can program it and operate it and potentially match the airflow exactly that you need for your project. So a lot of great features, and I'll elaborate on a lot of these as we go through today's presentation. Let's have a look at the high efficiency heating coil. This is a 3-pass hydronic heating coil with a very tightly packed close fin spacing, high density aluminum fins. The copper tubing is used with no lead solder, and the support mechanism is all, surrounding is all galvanized steel support frame. You get awesome heat transfer with this 3-pass hydronic heating coil. So one of the great features of this fan coil is that you can deliver heated air at very low water temperatures, and that ties in. I'll show you how in a few minutes. That really ties in well with a condensing boiler and how it operates. So it's a great match for a Viessmann Vitodens or Vito Crossel condensing gas boiler. The unit has an integrated hydronic pump. It's a 3-speed circulator with an integrated check valve, and it's a composite body. So it's going to provide the pumping you need through that unit, interlock with the water temperature going through the unit. The coil and pump are all built on a kind of a slide out rail, so you can pull that whole assembly in and out very easily and service it as required. So that all comes out of the front, and it's really like a lot of our Viessmann boiler products, designed with the service people in mind. So you can appreciate how easy this is to work with, and you're not battling with fighting it to get replacement parts in there if required. The capacity chart here is, again, a lot of this information is from our tech data manual, but I want to point out a few things here. We list the capacity of this unit at different water temperatures. So you can see here, starting at 120 all the way up to 180 Fahrenheit, you have the corresponding BTU capacity of that unit. And there's 3 sizes, the 213, 345, and 385 units. On the bottom, you see the corresponding required GPM of water flow that's required through that unit to deliver those BTUs. Now, one of the things that is unique about condensing boiler technology is the efficiency of the boiler is determined by the return water temperature. So you can actually determine the efficiency of that condensing boiler by how you operate your devices. So condensing boilers are such great matches with radiant floor heating systems, other low temperature radiation devices. And as you can see here, I can put this air handler connected to this unit and also create condensing temperatures. So in this example here, we're trying to deliver 60,000 BTUs to the heating load. And if I do it with 160, 140 supply return temperature, that condensing boiler is not going to condense because it doesn't see condensation until you drop the water temperature down below about 130, 125 Fahrenheit. So if I take that same BTU capacity and say, okay, let's run 140, 120 through that coil, then I'm going to get condensation forming inside the boiler and drive the efficiency of that condensing boiler up by 3 or 4 or 5%. So this does require a different unit. So you can see I got 60,000 BTU here on the 213, and I got 60,000 BTU output on the 345, but I can do that at a lower temperature. So it gives you the ability to play around with the output capacity and deliver BTUs in the condensing mode for that condensing boiler. And that's always our objective with the condensing boilers, is to maximize the amount of flue gas condensation you get. The Airflow Plus is cooling coil ready. We don't supply the cooling coil. You can choose the one you want. We just make it very easy to integrate that cooling coil into the system. The control system on this fan coil is completely pre-wired and has all the logic required to meet the requirements of the cooling system. And there's a lot of customization you can do with different flow rates and different cooling profiles and things like that. You got 2-stage thermostat input, so a lot of versatility with how you integrate and control that cooling system. But it's all built into the package with this Airflow Plus. And you can see on the bottom here the cooling capacity. from 1.5 ton up to 5 ton is the capacity of this unit to handle air conditioning. The combination of your heating requirements and your cooling requirements are going to certainly determine the size of the fan coil. A lot of times the cooling might be the primary load for this, and so that may determine how big of a unit you put in. But then we have the ability to modify the airflow for both cooling and heating, and I'll show you how we can do that later on with our control system. This Airflow Plus is really designed as a real tough, durable unit. It's got a built-in internal skeleton frame, which gives it really solid stability and makes for a real robust unit. You combine that with the fully insulated interior cabinet and the gasket seals, this thing is going to be tight and solid and quiet. And that's a real important part when you're trying to provide your customer with a very high quality heating system, because there's a lot of lesser quality units on the market which you can be noisy rattle boxes, and your customer, depending on where you're mounting that fan coil, your customer may not appreciate that. So we have heavy 20 gauge steel cabinetry. We've got a powder coated finish on those panels. They're also designed to be easy to work with components on slide out rails for easy service, and on the bottom you've got a built-in filter rack. So overall, a real solid piece of equipment. You'll really appreciate the quality we built into this unit. The Airflow Plus is also very easy to work with. So it's designed to be a low profile design, and this is very important in a lot of retrofits or basement conversions where you're dealing with basement heights or existing pieces of equipment you're replacing. It's a real compact design. The overall height is a bigger unit, is 34 inches. So that makes it real easy to fit in to your mechanical rooms. We do have adjustable feet on the bottom of that unit. So if you have a floor that's not quite level, or you want to make sure that your unit is nice and straight and plumb, you have the ability to have those are screw-in feet that you can. I think there's about 1.5 inches or inch and a little bit a play adjustment on those that you can really set that thing up exactly level and flat. The duct openings are fairly standard. I'll show you the duct return and supply duct opening supply sizes on this, but they're pretty standard. So the width and the depth are fairly standard on this unit. The other thing that's kind of unique is the carrying handle on the side here. We got one on each side of that unit, one over here and one over here. And again, just little features that make it easier to work with, so you're not grabbing a thing by the side and worrying about twisting or whatever. You got the nice little carrying handles, makes it easier to lift out of the crates, out of the box, put in place, move around, just really easy to work with. So let's look at that skeleton frame. It's kind of the bones of this unit. It's got a full 4-corner frame on this thing, which allows you to makes this unit very versatile to work with, and gives it this internal stability. So all of almost all of the panels are easily removable. The front, the bottom, and both sides can be removed with a screwdriver, and they're all, like I say, all Phillips screws. This allows you to reconfigure the layout of this unit very quickly and easily without having to cut any panels. And I'll show you how we do that later on. And that's important because most units of this type, you're required to get your tin snips out and start cutting out panels and making things to shape. We don't have to do that. So it's very versatile and easy to work with. And that also makes, in the future, service and maintenance very easily. You've got those screw-on panels, and if you need to pop the side off or the front off, or you need to get it apart, it's very easy to take those panels off and get access to things. So, for instance, if you're working on the pump at a later date, you can take the front panel off, but you can also take the side panel off and get at that thing very, very quickly and easily. So we have a lot of return air flexibility with this unit. The supply, of course, is always coming out of the top, but I can have left side, right side, or bottom return air connections. It's factory shipped left side configuration, but as I'll show in the next slide, you'll see how easy it is to reconfigure that. It does come with a bottom filter rack assembly built in, but we also supply a filter rack which can be screwed onto the sides if you need to go side return air. So you've got the built-in one on the bottom. That's the way it comes from the factory, but it's very easy to go to side mount if you require that. So a lot of versatility there. As you can see, the left side, right side, all those panels come off. So if you want to change, you just unscrew these panels completely off there and just switch them from one side to the other. So the opening is already formed, but if you want to flip that to the other side, it's just a matter of changing the panels around. And that whole process doesn't take very long at all because it's all threaded screws. So again, easy for service, easy for installation. So let's look at just some of the basic configurations. We're showing here on this drawing the location of the cooling coil, the location of the filter rack, and you'll also see here the location of the sensors. And I'll get back to this later on, but there's a bunch of sensors that are built into this unit. And this one here, particularly the supply air sensor, it comes with about a 15-foot wire on it. So, because it has to be located at different spots on depending on how you configure this unit. So in this particular situation, cooling in the supply plenum up here, the supply air temperature sensor is located downstream of that. And we would use the filter rack supplied with the unit and bring our return air into the side. And again, you can go left or right, as we showed earlier, just by reconfiguring that. So that's probably one of the more common types of configurations, but we can also go cooling in the return plenum. And that's equally as acceptable. One of the main differences is the relocation of the sensors. So we put a sensor up here now upstream of the cooling coil. So that's one thing that you may have to be aware of, is that depending on how you configure that, the sensors can be in different locations. And I'll explain about the sensors later on. This fan coil has a lot of safeties and features built in to protect the unit, and those sensors play a critical role. So you really want to make sure that you get those sensors in the correct location. Another configuration is bottom flow. That the only thing that requires, because you have the built-in filter rack already in place in the unit, all we have to do is take the bottom panel off and put it over, and it covers up the opening on the side. So again, everything is made to be easy and quick to work with. And in this case here, you don't use the filter rack that we supply as an extra item. Vertical discharge is also possible, and again, it's just a matter of reconfiguring flipping the fan coil unit, because it is designed, the ECM motor is designed with bearings that can operate in any direction. So it's possible to do this type of application as well. And then horizontal. If you want to hang the unit horizontally in a certain situation, that's no problem at all. Again, the filter rack and cooling coil and supply air sensors all have to be located accordingly. So those are kind of a quick overview of all the potential installation positions, and again, it just shows you the versatility of that unit. And again, with the multi-directional sleeve bearings in the motor, we can mount that it doesn't matter to the motor which way it's operating. It'll work just as fine in any of those positions. Okay, let's look a little closer at that ECM variable speed fan. This is of course, becoming more and more standard in a lot of units nowadays, but this provides a lot of benefits, primarily the fact that we can get the constant airflow that we need under varying static load air conditions. So you can dial in and get the flow rate that you need, and it will deliver that. The whole unit is that ECM motor is connected to a wide body dynamically balanced fan, so that gives you a really quiet operation. And the multi-directional sleeve bearings I talked about already. So it's a great feature of that unit. And if you look at from an airflow perspective versus exterior static pressure, you can see that the ECM fan gives you that constant CFM with increase in static pressure. You take a typical fan that you set the speed, but if your static pressure changes, if it's because of incorrectly sized ducting or the addition of accessories like electronic air cleaners, or your filter gets dirty, you start to lose airflow. Whereas the ECM is going to always give you that airflow. It's going to automatically adjust its motor speed to get you the airflow that you need. And the other great thing about the ECM motor is that our control system is programmable for different operating conditions. And I'll show you a whole bunch of variables that you can change to get the airflow you need under different conditions. So it's very versatile, very flexible, gives you very efficient operation. In a lot of cases, it improves the comfort level in the space because you're going to deliver exactly the airflow that you need. And in most cases, it gives you a very quiet, smooth operation. So a great feature. A lot of you are familiar with, if you're in the business, you're familiar with that technology, but it really is a great part of the how this whole unit works. Here's the fan and plenum specifications of the 3 different units, and you can see the horsepower, the nominal CFM, and the duct sizes for all of those different units. So again, as you move up, you get higher and higher airflows, and again, of course, the static pressure in the system and the ductwork and the accessories is going to affect the potential airflow as well. So at 0.5 external static pressure, you've got a lot lower flow rate than at the 0.2. And these filter sizes here are standard off-the-shelf unit sizes. There's nothing special there that we require anything different than what you're used to using there. So let's take a little closer look at that at the logic that's used to control this unit. And it really provides an intelligent control system built into this unit. It's designed to give you excellent comfort, optimal efficiency, and safety. It's going to protect itself against freeze-up conditions and low temperature conditions and things like that. The ECM variable speed fan can be customized. There's field selectable airflow rates, there's field selectable cooling fan patterns, and there's an optimized heating fan profile. So we're not going to blow cold air on people. That's very important to make sure that your customer is always experiencing high comfort systems. You combine that with the benefits of hydronic heating in other ways, with radiant floor heating and towel warmers and the ability to melt snow and all kinds of things. It really brings the comfort into the air side of the equation as well. So now, whether your air heating system is the primary or just a supplemental or just doing part of the building, we can give them exceptional comfort. And you combine that with a quiet, it's really a great combination. Quiet, comfortable, efficient heating systems. The controller also monitors constantly ambient air and supply and return air. So this is what we can use to really protect the unit. It protects the coils from freeze up, and it protects the house from getting in a freeze up condition. And I'll explain how that works in a few minutes, how these sensors, there's 5 sensor locations which really feed back information into the control and protect itself. The other thing that we get is alerts. We can alert through an alarm system or a building management system or a home alarm system of a potential fault. So we're going to alert with flashing lights on the unit. We're going to alert with, in some cases, with an audible beep, and we have the ability to have that tied into a contact to enable an output to another management system. So a lot of potential things going on there, and then I'll explain some more of these as we go through this here. So this is a little descriptor here of the field selectable flow rates that we can achieve with this unit. And this is just the dip switch settings for one of the units. There's a different chart for every unit, but I've just chosen the small unit here so you can see. The factory default is in this middle section here. And you can see for heating systems, it's 910 CFM, and for cooling systems, it's 1290. But with these dip switch settings here, I can adjust the airflow for heating up and down, and for cooling, I can adjust it up and down. Or I can change this dip switch here and get into one of these profiles. So basically for heating and for each heating system, you have 12 selectable options for the CFM you need for the air heating system. And I've got 12 selectable options for cooling. So you can really fine tune the airflow that you need for both your cooling and heating systems. This is the factory defaulted heating fan profile. And so what this shows you is once you've selected your 100% flow rate, which is up here, so say it's 700 CFM, you'll get that during this part of the heat up cycle. But when the unit first starts up, it does kind of a soft start. So for the first 15 seconds, it doesn't run the fan at all. It just runs the pump to heat up the coil. And then it slowly brings the fan on to varying speeds from 25 to 50 up to 100%. So that allows your ductwork to heat up, allows your heating coil to get hot, and avoids, again, blowing cold air on people. And so it's also going to reduce the noise of a startup. You know, when your heating system first comes on, you're not going to hear that great big whoosh of air as the thing starts up. It's going to be a more gradual, soft start until you get up to the 100% speed. And then at the end of the call, it runs at 50% for a minute just to bring some of the heat out of the coil and push it into the space. So that's a standard profile for heating. It's not adjustable, but when you get into cooling, there's 4 cooling profiles. And this is the factory default setting. Again, it's a softer start to bring you on slowly and then ramp it off slowly. And you can see that's the factory default. And then this one here is one of the optional settings. And this is another optional setting. So you've got 3 different cooling, and there's a 4th one. There's 4 different cooling profiles to choose from. I don't profess to be a cooling expert, so it's going to depend on what you need, but it does give you that ability to change the cooling profiles. I'll just flip through them again there. You can see that there's the factory default. In most cases, it'll probably stay there, knowing most technicians just leave things at factory default. But again, if you need to address certain situations, bring the fan up faster, leave it on longer, we have that ability to do that. So those are the 4 different settings. And we're showing here on a lot of these, some of these slides here, these dip switch settings. And I'll show you where those are. This is the main control board here, and you can see there's 2 banks of dip switches, one here and one here, and the on and on switch located. And those are the dip switches that we can use to customize how this control system works. So this is the main circuit board, and it really manages the whole system. And all the operational and safety features are managed by this control board. Primarily what the installer is going to do is get in on this side here and maybe change some of the temperature sensors. As I mentioned earlier about the supply air, return air connections may have to be changed. That's the return air there. And the discharge air here. You may have to adjust some of the dip switches from factory defaults. You have your thermostat connections along the bottom here and your outputs on the side here. So I'll show you how that works, and we'll go through some of the diagnostic information and alarms that control gives you. You also have the ability to easily integrate other pieces of equipment with the Airflow Plus. So of course, cooling system is an absolute, but you also have the ability to add other auxiliary devices such as air cleaners, HRVs, humidifiers, etc. So it's a very versatile control system. And so let's just have a quick overview. The top left connection up here is your power supply in. Next, the output to your circulating pump. You have a transformer here to drop down the 24 volts. So those are pretty standard. This is all the outputs here for the ECM pump. So there's a big multi-plug here for your ECM fan. There's a lot more detail in our installation manual on all of the terminals in there. So if you're doing any troubleshooting and servicing on that ECM fan, it's very easy to work with. I'm not going to get into that here because that's more for our technical training. And then we get into our low voltage outputs. So there's multiple outputs from this fan coil that allow us to control different pieces of equipment. So first off is the air conditioner relay. And This is a relay that's active when the cooling thermostat is calling for cooling. And the important thing that we want to point out here is that the 24-volt output should be connected to the air conditioner contactor, because some technicians are used to just using the cooling thermostat connections to activate the cooling cycle. But we want to make sure that you're also connecting the power contactor here to this unit here, because that gives the fan coil control over the cooling unit. And that's very important because we have a bunch of built-in safeties on this unit which prevent coil freeze-ups. And if we don't have this connection tied into your air conditioner, we can't use those safety features. So it's a very important point on here is to use that air conditioner relay. And I'll show you in our diagnostic sections later on how some of this comes into play. The heating relay dry contact is where we enable our boiler or give our heating device a call for heat. So that's typically connected to the TT connection on the boiler, or in some cases with Viessmann Vitodens boilers, you may be tying into the additional heat demand contact on the Viessmann boilers. It's not called a TT contact, but that's where we enable the boiler, tell the boiler, yes, there's a call for heat. The fan relay, if you have the fan relay is active anytime the fan is running, and it can be used to activate external devices. So if you want to turn the air cleaner on every time the fan's running, or the humidifier, or whatever the case may be, anytime the fan comes on, there will be power on this relay. And the last contact output is an alarm relay output. This is going to activate whenever there's an alarm condition, like a coil freeze up or a low heat scenario. And it just gives you a dry contact to a building management system, or some sort of, like, you could hook it up to a light or a buzzer or whatever. But typically that's going to be some sort of building or home automation system that activates and tells someone that there's an alarm condition. And a lot of these new building automation systems nowadays have the ability to dial out and send a SMS message to a contractor, or start calling people, and so you can really get right away a message to your smartphone saying, look, there's an alarm condition on this unit. There's also an audible alarm, which I'll show you. We'll see that there's other things that happen when the alarm comes on. The thermostat, there's factory installed jumpers on the heating and cooling terminals, because you have on both of these units a two-stage heating and two-stage cooling option. So if you're using a single-stage thermostat, you just leave the jumpers in. And of course, if you're using a two-stage thermostat, you take the jumper out. But it does come factory installed with those jumpers. And then you have your sensor inputs. So let's look a little more detail at those sensors. You've got a supply water sensor, a ambient air sensor, a return temperature sensor, a freezing protection sensor, which is located up here, right adjacent to the coil, and a supply air temperature sensor. That one is located, when it's shipped from the factory, you get a bundled wire of approximately 15 feet of, and that should say 15 feet of wire, and you can just stretch that up through the cabinet and poke it through into the airflow. So that has to be mounted on site. So let's look at some of the features that are tied into these sensors, because we look at it kind of like a 5-star safety system. You've got 5 sensors which are always monitoring what's going on in that system, and it will make different things happen depending on what those sensors are reading. So let's look at first at the low supply water temperature function. Temperature sensor, starts out, is located right on the outlet of the pump, and it's measuring the supply water temperature going into the hot water coil. And what this does, it will shut the fan off during a call for heat if the supply water temperature drops below the required temperature. So factory default setting here, 110 Fahrenheit. You can adjust it lower if you want. And what that does is it really prevents cold air from blowing in the house. And having a complaint from a customer, the fan's running, there's no heat in the wintertime. So this will typically happen in a couple scenarios that we see, certainly during domestic water priority, when you've got a boiler that's doing domestic water and space heating, if it flips over and starts generating domestic hot water like a combi boiler does, or with multiple pumps, you could see that water temperature start cooling down in the coil. The fan still running, but now the pump will it will turn the fan off if the temperature drops below the set point. So excellent also for scenarios where you have long pipe runs feeding the fan coil. So if it takes a while for heat to get to that coil, again, you don't turn the fan on until the temperature gets above a certain set point. That's a great feature for maintaining comfort in the space. There's also an ambient air temperature sensor located right here on the outside cabinet of the unit. And what that does is really protects against a potential freeze up in the house. And what it'll do is if this measures a temperature less than 4 degrees Celsius, it will turn on the pump, the fan, and enable the heating boiler. And this is going to protect the house from either one of two things, either a defective room thermostat, or if someone accidentally turns the thermostat off or leaves it in the cooling mode and it gets cold outside. So it's a great feature just to protect. Now it will not completely protect against the freeze up in the house, because there's other scenarios where you could have power failures or other things like that. But it does help address those scenarios where someone goes oops and leaves the thing in the cooling mode and goes away for the weekend or whatever. The heating coil freeze protection function also protects the heating coil from seeing too cold of a temperature. So there's a couple of parameters here based on those supply and return temperature sensors. If they get below a certain point in temperature, then it's going to do a couple of things. It's going to shut off the air conditioning relay if that is running at the time, but it's also going to operate the pump and fan to get some heat going through that coil, and an alarm relay will be activated. So it's just a protection in case something goes wrong with your air conditioning system or something else going on in there. There's also protection for the cooling coil, so you don't freeze up your cooling coil. If you've got, for instance, a plugged filter and you don't have enough airflow and you get a very high delta T, then it's going to recognize that, looks at the supply air delta T between return air and supply air, and it will shut off that air conditioner relay for 5 minutes and give the whole thing a chance to warm up a little bit. And if it keeps doing that 3 times in one cooling cycle, you go into a cooling lockout, everything shuts down, alarm starts blinking. So this is another reason why we really want to have control of that air conditioner relay, because you can see in both of these scenarios here, in the previous slide, heating coil protection, and in this slide, cooling coil protection, we need to be able to shut that air conditioner off to protect the unit. So just something that's built into this unit, and it's a great feature. The last function I want to talk about, there's 2 functions that are kind of related here. Maximum heating limit, and the next slide, minimum cooling limit, are kind of related. I'll go back to this one here. Maximum heating limit, also referred to it as the landlord setting. The factory default is 90 Fahrenheit air temperature, but you have the ability to disable a heating call if the return temperature exceeds a certain setting. So if the landlord wants to say, you're not getting higher than 80 degrees Fahrenheit in that space, then you can set that and it'll shut off the unit, or 85 or 75 or whatever the case may be. So it's just a matter of changing dip switches, and you can control how hot the temperature gets in that space. So you can't have people opening up their windows and turning the thermostat up to 90 degrees. That tends to happen in some cases. So this will disable this. And it's the same on the opposite on the cooling side. It'll disable the cooling setting based on whatever your settings are here, 15.5 all the way up to 22. So it just allows you to set the coldest possible temperature that they can set in that space. Okay, so those are the basic functions that come into play with those sensors, and it really gives this Airflow Plus unit a lot of unique safety and performance features that are going to enhance how that system works and give you some peace of mind as well. So on the very front of that cabinet, you see also the little LED light. This is the light, and this is the ambient air sensor. And that light is used to indicate a number of different things. In normal operating mode, if there's nothing wrong, it flashes a certain sequence to indicate what the temperature is in different sensor outputs. So for instance, if the red one flashes once and then you get these series of 3 and 6 green lights, that indicates that T1 is reading 36 degrees. So it's just information that can be useful if you're diagnosing different problems. It'll cycle through the different sensors as well. So you do have to stand there and watch what's going on. You also get different flashes if there's a failed sensor. So for instance, you'll get a whole sequence of flashing reds if there's a failed sensor. And the third thing it does for you is it tells you if you do have an alarm condition, the LEDs tell you what that alarm is, whether it's a freeze protection or a cooling lockout or whatever. It will show you what those are. So very nice diagnostic tools to quickly and easily see what's going on in that system. You also get certain air conditions will initiate a beep code. And you can see down here, after right away, if the air conditioner is locked out, you get 4 beeps. And then you get after 24 hours and after 10 minutes, you start to get different things happen at different times. So just another feature that's built in so that if the customer's in their basement, they hear something beeping and they see the lights flashing, and they maybe give the contractor a call to say, something's going wrong here. And you can make the customers aware that, if they do hear a beep, there's something wrong. And then they could even read off the flashing codes to you and let you know what the code is so you can know right away what it is. So some great features there. Okay, the last thing I want to look at with this Airflow Plus is some of the system layouts that are possible, piping layouts. And first and foremost, we show this scenario here. This configuration is not possible. What we're showing here is a direct connection of a Vito-Denz boiler to an Airflow Plus. And the reason why we're saying this is not possible is primarily because of the fact the built-in pump up here in the Airflow Plus only has so much capacity to overcome the friction loss of the coil and the friction loss of the heating system. And in almost all cases, it's not capable of doing both. It just doesn't have enough flow and head capacity to do that. So you got to be very careful there. And in most all cases, you'll have to go with primary secondary. The one boiler where it is possible to do that is the CU3A, the Vito Crossell 300, because this boiler is a high mass, high water volume boiler, and it doesn't have any friction loss through the heat exchanger or almost negligible. So in this situation, we're pretty confident in almost any situation, the Airflow Plus built-in pump is going to be able to handle that friction loss. So you'll see that in almost all other configurations, we show this. Low loss header, you can also use, on-site closely spaced tees as well. But and then they work the same. If they're done, if you do the primary secondary piping done correctly, it's exactly the same function as a low loss header. So we show in our drawings low loss headers. So in any of the low mass heating boilers that we sell, that'll be the Vito-Denz 100, Vito-Denz 200, and the 222F, we always show this primary secondary configuration. Where we get into different scenarios, and then some of the different layout drawings I'll show you here is just different combinations of domestic water and heating and multi-zones and things like that. So in this scenario here, we're showing just a straight heating situation, and we're making a comment here that the fan coil can use outdoor air reset. So you can vary the water temperature going to that fan coil, or you can use fixed temperature if you just want to use, don't install the outdoor sensor, and you just get a fixed temperature supply from that boiler. This is an example showing the Combi Plus unit with a built-in domestic water instantaneous generator on the bottom here. And you do get priority on domestic hot water, of course, because there's a diverting valve built into here. And of course, we got primary secondary for the space heating system. And we can have outdoor reset on that fan coil or fixed temperature. Now, when it comes to domestic water priority, we make a comment here. The fan coil logic is not affected by domestic water priority, but it does not get hot water because of that diverting valve. So what's going to happen is that the fan coil will all of a sudden stop getting heated water. So what's it going to do if it starts seeing the temperature cool down? that low water temperature protection is going to kick in, and the fan's going to shut off. So you in effect get a kind of an indirect domestic water priority on the space heating because the fan coil doesn't see hot water, it's going to shut off. So you're not going to blow cold air on people, and you've got the full capacity of the boiler for domestic water production. Here's another example here, exactly the same logic, except for now we've got two pumps. We've got an indirect tank off of that boiler. So boiler doing domestic water heating and space heating. And then another scenario here is with a multi-temperature heating system. Now I've got fan coil heating and floor heating. Very common combination where you may do floor heating in the basement, fan coil on the upper floors, maybe some floor warming in the kitchen and bathroom. And again, here with the Vitodens 100, you probably would use a third-party multi-zone controller to control these two heating circuits, and you would use some sort of tempering valve or a motorized mixing valve on the radiant floor system, because now you've got a two-temperature heating system. But the heating wheel pumps will still operate during domestic water production, but they just won't get hot water. So again, that same sort of logic kicks in there. Now in a multi-temperature heating system with a Vitodens 200 boilers, now we've got the Vitotronic control. And that's a multi-temperature heating controller built into the boiler. So you don't really need any aftermarket controls here at all. We can control motorized mixing valves. We can have two heating curve settings for the two different heating loops. We've got domestic water prioritization on this side. And as it relates to the fan coil, you have two options on how you call that heating system on. You can run this into the heat demand contact and run it as just a fixed temperature coming from the boiler, or probably makes more sense in our opinion to use the heating circuit 1 outdoor reset curve and set up a heating curve for the fan coil. So then you've got two temperatures being provided by the boiler. You can set up the water temperature exactly what you need for that fan coil. 222F is very similar. In fact, it's almost identical because it's got a low mass heating boiler built into it. And again, low loss header, Vitotronic multi-temperature controller built into the unit. And this is a real nice combination because you've got boiler, domestic hot water built into one unit here with the 222F. And then you have a fan coil floor heating system on the side. So this is a great way to upgrade even a forced air home to a modern hydronic system with the ability to do some floor warming and floor heating off of that boiler as well. And again, if you took that floor heating out of it again off the side here, this becomes a great replacement for a traditional water heater furnace. And in our opinion, gives you better performance on both. The 22F is going to outperform most any 50-gallon water heater on the market, and the fan coil is going to give you more features and comfort and quietness and performance compared to most any furnace out there. And with all the adaptability of control, it makes a real powerful combination. The last scenario I'm showing here is a high mass boiler, such as the Vitocrosso CU3A. This is the scenario where we don't show a low loss header or closely spaced tees because the boiler doesn't demand it. So any high mass boiler or any device that doesn't have flow restriction could be connected to this, have the fan coil directly connected without need for closely spaced tees or low loss header. And again, all the other things apply. Multi-temperature heating control with the Vitotronic control and all of their same sort of priorities with that domestic water priority. So there you go. That's in a nutshell the Viessmann Airflow Plus unit. Some of the great benefits you can give to your customers. I think it first starts out with comfort, consistent air delivery temperatures, quiet, and noise is a comfort level as well. When we talk about comfort, we usually think temperature, but to me, it's all about noise as well. It's not a comfortable environment to be sitting in a house that's got roaring fans. So quiet, comfortable, consistent air delivery is really what this is all about. And from a standpoint of dependability, it's like every other Viessmann product. We build them to last with dependable, long-lasting components. Versatility, multi-position mounting, no cutting of panels, easy to handle and install, easy to service. So again, great features that you're used to with Viessmann boilers. Built-in safety and protection features give it some really exceptional features to offer your customers. And then it's pre-wired for heating and cooling equipment. Overall, the perfect complement to a Viessmann boiler system. So that is all I have today on the Viessmann Airflow Plus. There's some information here on how you can learn more by going to our website or attending one of our seminars. I'm just checking now to see if anyone has any questions. Let me see. Is the pump bronze or stainless? It's neither. It's a composite body pump. So it's certainly non-corrodable, so it could be used in an open loop system, but it's not a stainless or bronze body. It's a composite plastic body pump. And I think Mark has answered some of these questions on the side here, so I'll jump to his. Who is going to do tech support for this unit? We are tech support from our department here. Okay, so that's about it for questions. I will wrap up and just say thank you very much for attending. We appreciate you joining us today and appreciate you taking the time to sit in on our seminar, on our webinar. So if you want other people to see this webinar, there is going to be a new section on the Viessmann website to view this webinar again. There's going to be a webinar archive section of our website where you'll be able to download and live stream any of these webinars, that including this one, at a future date. So you can sit down and watch it again at any time, or get other people in your office to sit down and see it as well. So thanks again, and see you again next time.